Hello, my friends, and welcome everybody. How's it going, chat? Let me just close all of my work. What I previously did. Let me open. Yeah, we need a C-Lion. And remember that we are going to switch to Vim completely on Monday. So bye-bye fancy IDs. and bye my 3-year, or I guess 5 years subscription with full discount. Okay, so we don't need documentation anymore. We don't need algorithms. We do need RoadRunner in Rust, and we do need Gorge in Rust. Algas, I'm sorry, a little bit later. Okay. Go on here. Boom, like this. And here we need to open SDK. Okay. So almost done. SDK. Yeah, everything is right. Okay, so I'll remember that on previous stream we did super cool discussion about the how we can apply our stdr, stdin, and stdout channels inside the threads. We also where's Tauri UI Rust. We also had some inspiration from the Tauri, and basically from the Tauri, let me find this, from their approach how they work with the processes. Actually, we can clone this repository and use it locally. Command new. Yeah, so I do not want to install remote extension, remote development. Yeah, so I was inspired slightly about their approach, how they use threads with the channels. I'm sorry, thread with the with the channels, but so it's like, for me it's like Golang channels. Let me open a stream on my mobile phone. Okay, so and error node. Also, for sure, we have to open error node and our super plan. Yeah, this is our Red Hat plan. And here we are going to do the following. So we have 3 channels here. All of them represents one of the pipes. For example, stdx, stdout sender and stdout receiver represents stdout pipe, stdin, and stdr represents stdr pipe. And basically, original idea is to run started threads here, which would be like read our part of the data. For example, if we want to send something into stdout, or I'm sorry, stdin, so we have to use our stdin sender, yeah, and stdin receiver would be on here in the thread, and vice versa for the stdout, for example, and stdr. Also, we don't need to send anything into the stdr. We only receiving the data from this part, so don't need to do actually anything with the stdr. Okay. So we have to do the following. Let std out. Let's try. Let mute std out is equal to command stdout take. Okay, we don't need make command mutable, sure. And then here we are going to start. We also have to yeah, we also have to have some kind of terminated channel, you know. So for example, if we need to stop everything, we can just drop everything here on all the channels, but instead I would prefer to have like some kind of similar to Go approach, like to send a channel and use a select to read from these receivers. And for example, if you have an like signal to stop, we just like exiting from these threads, so without leaving them opened forever. Okay, so and now we are going to do the following, like while let some std out, let's use std in first. Is equal to std in receiver receive. It's not. Oh, it's result. Okay. Expect can't read data. And here, let mute std in. Okay. Oh, I'm sorry. We should. Why we use this std in? Std in like let us call it data, just for the sake of simplicity, you know. Let me just I'm sorry, I need to answer my question about regarding to work. Let me a second. Okay. Let mute data. Remove variable data. No. So okay, when we receive something from the std in, we need to send it here. Send. Like send. But we don't need this. So we only would have a data, and we only would have this. We don't need all of this. And so can we and I'm sorry, guys. Okay, so we can do this. Yeah, we can import and the moment of truth exist on enum. Oh yeah, so I guess we need to do this like this, and here we're going to child. Yeah, and now make child mutable. Type annotation needed. Okay, type annotation would be as would be a frame. Okay, so let me comment this just to see if everything compiles. Okay, send. We don't need this anymore. And we have an error. Oh, error in the tests. So also let me comment all of the tests temporarily to see if we have an error. Yeah, we don't have any errors. This is nice. That means that our approach works, and we can do basically the following: attach pub std in tx is sender frame, and get here, and std in tx would be our std in tx. Bam, like this. Awesome. And actually, what we did here? Where is our endless loop? Actually, let me do the following. So here we should have an endless loop. And actually, the problem, if we would have an endless loop everywhere, so if we use this thread like we use here, we receive only one frame. So when we spawn this thread, we receive only one std in one package, one frame basically, and send only one frame. But we need to continuously send and receive the frames. And in this case, so I'm also afraid if we would get into some weird state Yeah, so this is some very important. Jolly hey yo! Missed a few streams. How's the progress? Oh, progress is very good. I rewrote, I guess, 3 times everything. Thank you for the borrow checker. Thank you very much, Rust. So basically, the problem, the problem with Rust, Rust is too safe. You know, it's too safe, and this is super cool. If you look at this, basically, how I can, yeah. If you look at this code, this is our application, and I like get some inspiration of from their code how these guys doing like connecting the pipes with the actual pipes of the process. So they doing like OS pipe system call, but yeah, I wanted to avoid system calls as much as I can, and so in Go this looks super unsafe, like super unsafe. But as we see here, they use an atomic reference counter. They clone the child. They use read log, and they use channels, like, so a lot of like layers of safety. Then to receive the data, for example, to wait, they did awesome things like using a guards to correctly like remove or send the data. But in Go, if you'll see how it works in Go for us, this would be super scary. As we see here, we just wait, and so when process exited, we're like, okay, let's go and relocate the worker. So yeah, we do have some logs here, but this approach looks super unsafe, like super unsafe in Rust terms for sure. Yeah, and and this is super cool. And here we talked with one guy yesterday how to create super safe approach, and we designed a few plans. Previously we had this plan called Yellow Hat, as you may see here. Yellow Hat was totally like destroyed by Rust borrow checker, so this is not possible to take out of the option std dot and std, and then work with all of these pipes independently. And we designed a new plan called Guy with a Red Hat, Red Hat, and this approach uses channels. And we invented this plan independently of how the other guys doing this like pipe connections. And as I started searching for the another approaches, other project work with these problems, and almost everyone uses channels to work with it. Yeah, so for sure, Go is not so impressed. I watched a stream of the Primagen, I guess yesterday, and he was 2 guys and a chat ranked programming languages, and yeah, Go almost get into the dog water rank. But yeah, so Rust is completely like beat all of, so everyone agrees that Rust is A tier, programming language. I had when I started to stream, the guys from work started to write to me about the problems. So like the usual thing, and I have to deal with these problems. They started to resolve my tickets on a Friday evening, and had a lot of questions. Why this works like I described? Why this doesn't work? Why this doesn't work? So like, okay, so I have to use like mobile phone here to answer on these questions. I'm super sorry about this, but I have to do this. So okay, how was your day, Virgin? Why you decided to read some Go code? After Rust, you have to be like okay, suicide mission. Read the Go code. And a small part of how new API gateway is written and going. Okay. So have you like proposed to bosses to rewrite this in Rust, like we doing on the streams, like rewriting everything in Rust? So they should agree, like. Oh, most of it's already in Rust. Why? Why so? Oh. Yeah, so Go have, I guess, broader support for the like Kubernetes and all of the things since they are written in Go. Yeah, and I guess a lot of libraries written in Go for the Kubernetes, like some Kubernetes CLI and clients and etc. So yeah, I guess this is probably like better choice if you don't need super high performance. And you know, Go is not a like super bad programming language. I do like Go for the like I don't know, for the simplicity, for the like syntax is also like good. I can say that syntax is like super bad and disgusting, like, and but Go, I guess the Go started the way like JavaScript. Yes, I guess like JavaScript, TypeScript, this way. Not a Pythonic way, because Python is some kind of I don't know, dynamic programming language like PHP, but they started to go like I guess like JavaScript with yeah. Oh no, actually, so this is I don't think that the if r is not equal to nil is too bad, but you can compare this with much. You know, everybody loves much, like this much with things, but nobody loves if r is not equal to nil. And everybody loves C return types like -1. They don't have even like error types, so -1, everything's bad. So it's kind of choice. I don't know. So I don't think that. I don't think so. So I where do I have this? If r is not equal to nil. If r, how much? 7. 7 if r is not equal to nil, for like 415 lines of code. So almost 2. So basically, this is a very small percentage, and I don't know. So I'm totally fine with the r if r not equal to nil. So I don't know. I don't like in Go. Basically I don't like that they use runtime. So if so since they yeah. So they so bothering me with these problems on the work. Yeah. So I personally so Golang was when I finished working with C#. C# was overloaded with like sugar. There's a ton of the sugars in C#. So async awaits. This is a good part. Like async awaits, task poly library, everything so fine. But they started adding like I don't know, super big amount of sugar to this language. And when I moved from C#, it was like I guess in 2017, somewhere around this, when they started to release the core library, I switched to Go, and these times Rust won't be so popular. So Rust was released in 2015, and I looked at Rust. And I thought I want to switch from C#, but I don't want what language I have to choose to switch for. So I have a Go language from Google with a good support, with a good standard library, with like a fresh air, like channels, no OP, no everything of. So it's like lightweight, easy to write code, like high performance. It outperforms. So we have one project, and guys asked me to write some high performance core, like algorithmic core, and I in Go, because their solution in C# like used a lot of CPU, a lot of memory, and this core library have to support a lot of the WebSocket connections and should be like kind of low level and super performant. And as you imagine, I wrote a solution in Go which can like use, I don't know, let me just double check to not like fool you. I just say you. So 34,000 of connections and device connected to this socket, and all of them use only 0.03% of CPU while working, and 1.24 gigs of RAM. So this is for 34,000, and this is like super numbers, because solution written in C# used like 10x of all of these resources. Yeah. Okay, so I think I resolved this question. Fine. And yeah, so Go is kind of good. Okay, so I can write this in Rust. So I don't think, do we have WebSockets, Rust, some kind of official, might be, or a solution from a big company? Do they have? So when you're writing a production code, you have to think about support of the library which you're trying to get as a dependency. So this is number one. I don't know, like the rule in 100 rules in like how to work in enterprise. You can't just think that you get some super cool solution from a single developer who wrote this solution on GitHub, for example, and use it like, I don't know, and so like for years. So it's preferable to use some kind of solution from a big company, for example. So for sure it's not applied not for everything, but yeah, I can get a solution from Rust, but so the time when I wrote this core library, RabbitMQ, which used in this project, was not so super cool support from the Rust, and yeah, so I decided to write this in Go because it was like faster. And yeah, so this is also kind of performant programming language. I can say that there's some kind of competition between Rust and Go, so I guess Go becomes like a backend, I don't know, backend JavaScript like thing. I think like this. It's like modern fancy programming language. And Rust becomes complete replacement for C++. I don't think Rust replaces C like completely, because there are super like big amount of code written in C, but I do think Rust will replace C++ entirely, because C++ is like dog water, like it's a complete mess. Yeah, so I'm not blaming you for working with PHP, because I'm also write a small amount of the PHP code. So today I wrote, I guess, few letters in PHP. I fixed a variable name. Yeah, so PHP gets into the category as the same with I can't remember this JavaScript from these guys. Yeah, so this is completely fine. So I don't think that PHP is like a bad language at all, because PHP was completely bad when it was like version 5, I guess, and something like this. Yeah, this times PHP was super bad, like, but now I don't think so. So PHP is kind of like kind of speedy programming language, if I can say so. It's easier to find developers with the PHP stack, so it's easier to like have, for example, me who wrote and RoadRunner, and like with Anthony, and like having generics. You mean in PHP? I thought that PHP have a generic. No? Generic in PHP, the basics. Generic. Nah. So yeah. How to make function generic. So we can write like this and check if it's not int, then return null. Oh my god, who wrote this? Type, yeah. Now, to be clear, PHP doesn't have generics. Okay. Yeah, I heard about thing called PHP stan, maybe, or like, so this big thing written on at the top of the class or function. Yeah, I'm just like guessing. I don't know the actual name. Yeah. Psalm, yeah, whatever. Yeah. So yeah, having generics would be, I guess, really nice for the PHP, but yeah. Okay. So this syntax in these brackets like doesn't exist. Oh, but PHP nowadays I think have a lot of RFCs and have a lot of like developers who develops the core of the PHP, like, and I guess it would be introduced very soon, since a lot of people like think it's would be nice to have. "10 years. Oh my god. 10 years. And no one wanted to implement it, yeah? Oh, it's an RX. Generics. Oh. do they started to implement it, or it's just like RFC for the RFC, like not for the implementation? 5 years ago. Oh. Yeah. Sad to hear this. And yeah, status draft. Yeah, still waiting, like 10 years. You can wait another 10 years, but yeah. So I guess PHP is good scripting language. I don't think it's like, I don't so if take into account only modern PHP, like version 8, I think it's pretty good. And like, I can't blame developers who use like a PHP anymore. Like, so the time of these jokes already gone in the history. Okay, so yeah, we can't do this. We should like use std in here, and we can't use and expect file to write into the std in. Okay, what do you want? Oh yeah, mutable. Okay, fine. Type annotation is needed. I super excited with this error error messages from the Rust. It's super cool, you know. Basically doing proper generics. Yeah, you're right. So I don't like generics in Go, actually. So generics in Go are super stupid. Like, I expected they like Roscox and other guys like from the core team always told us, like, okay, we have to, so we don't want to introduce Go 2, we want to like did everything correctly, and then they introduced it this. Like, I don't know actually. So where I don't have the generics here. I guess I have a generic in priority queue, might be. Yeah, and then they are introduced this, like this, square brackets. So you have to use this on the functions, this T, and they are super limited. You can't assign generic fields. You can't you can do a lot of things with these generics, and basically I don't think they work slowly, like significantly slowly, if comparing to the native types. For example, if you native types, I mean native implementation, if you implement this in type, they don't use monomorphization. So I don't know, I actually don't like generics in Go. I somehow use them in some like circumstances if I like want to experiment with them, but actually I don't think that like the generics is the thing which will work like on a par with the interfaces, for example. So I think, as you may see here, item here is an interface. I can't have in Rust like super general things here, like as reference, for example, or as into string, for example, like I can do in Rust. So I can accept any type then that can be translated into the string, for example. I have to use a particular interface here, or I can use unions. Yeah, for sure. You know, I know there's like unions. You can use like numeric types, for example. But this is, I don't know. I don't like this approach. After generics in Rust, so this looks for me like super ugly. For example, I can replace here as a string with type like this, t as ref of like this, and have thing like this, and this will continue work. And I don't have this ability to implement like this in Go. So I have to use these interfaces or other interfaces, so but some kind of types, and I don't like this approach, completely don't like, and I avoid like using generics in Go. And was the generic implementation for me was a last like thing which after which I decided, okay, so I don't want to work in Go anymore. So I want to switch into the Rust completely. Okay, so here we should oh yeah, so we can't use this as ref because we use a slice. Yeah, but we can replace this as a slice as refs. I guess this should work. As ref os string. Oh yeah, maybe it's not os string. Yeah, but let me use at this moment my basic type here. So but basically I think you get the idea. So in Rust I can use so generics are super powerful. And what type annotation you need for what? T declared on the channel. Yeah, I guess std in, where you do need this child std in. It's not from here. Frame result. Okay, I think it should be here, like frame. You don't like this? Why? Extra fields found in the tuple struct. Oh, this is a tuple. Let me see as error. In Rust, I so excited when I see, okay, I have an error. It's super cool. And I wanted, oh, yeah. So I have to use turbofish pattern. Like this. Consider specifying generic argument. Like this. It's super explaining what we have to do. Okay, frame mutable. Yeah, sure. Okay, cargo build. Boom, everything's fine. And this is safe. What I do like in Rust that since I use a thread, yeah, and in Go I like I can be sure if I like even I use like logs here and use like defer, mutex, unlock. I have to use things like this inside the coroutines because yeah, you just can be sure that someone uses resource. And if you run with raise a flag, this thing, you have to write a test which is like trigger this raise condition. If you write improper test and won't trigger this condition, let God save you in production. Okay, so next thing to implement. So here, guys, we implemented std in. I'll remember we're going to send the data into this std in channel, and this would be like our thread. We should work continuously, and we are going to just to just consume this from this receiver part and send this to the worker. Only one thing I'm worrying about is that we need to so we also need to have this the same thing for the std out, but we are going to receive from the std out, and the problem here would be if we have so we should do this synchronously. So we should like send, receive, send, receive, send, receive. We can't do like send, receive, receive. So if we do a thing like this, send, receive, receive, this will break our API completely. And since we're using this in threads, still we have to use this like in a synchronous way, because you know, this is PHP under the hood of these processes, so we can't control all of these kind of things. And also the problem inside PHP is that if you have some kind of library, yeah, for example Elasticsearch, as far as I remember, so Elasticsearch can send data into the std out like just randomly, you know. And in this case, the entire thing will fail. And we have to think how to synchronize all these sends and receives. So it's not a problem for the stdr, because yeah, stdr is basically, for us, stdr is just like, okay, we're receiving any data we send to the workers process stdr, and okay, this is fine. We just resending this data into our process, parent process stdr. Okay, let's deal with std out. We also have to use turbofish and also send let me use std out is equal command std out take and thread spawn like this. But now here we definitely should use some kind of, you know, select statement like this, and use like a stop channel for sure, because here so we are receiving the data from the std out, and so the other problem here with our std out, so this is our actually function we should like use inside the std out, and as you may see, there are like, comparing to the std in, so like 1, 2, 3, 4, 5 lines of code, actually like 4, but actually like 3 lines of code compared to this, all of this stuff. And here, since we are receiving the raw data, would it be possible to make RoadRunner worker main loop to play well with? Yeah. I don't think that this is the problem. Run is not limiting you on, I think, implementing. I guess one guy already did this. Let me just check. Fiber. Too close, and I close this issue. Split monolithic, or no, it's not in the RoadRunner, it's inside spiral RoadRunner worker. Yeah, like this. And this guy already did some kind of investigation on this, and like with the removal of fibers, and he did some tests, I guess. I don't know the actual state of this feature. I actually don't know what is like fibers are like, just like processes, or I don't involve on this thing. But according to this investigation, it's like eight workers, are each capable of handling 100 connections, and 800 jobs. Sleep 1 in just 4 seconds. So with RoadRunner, the same would take 100 seconds, which is expected. Like 100 concurrent connections, sleep 100 seconds. So yeah, 2021. It's like exactly on this somewhere on this day. Oh no, it's like 2020. Yeah, 2021. I was in a hospital dying from COVID. November, as you may see, my station, my commits history. Where is it? 2021. Yeah, and you see this like this empty space here. I was like committed. It's like temperature 40 was here, like, and I need to release RoadRunner, I guess 2.10 release, some kind of bug fix. I was like, oh my god, I have to fix this shit. And then I was like, okay, I can't breathe anymore. I have to go to the hospital. So I call an ambulance and I was delivered to the hospital. And this is like, you can clearly see this on my commit history. So it was like, okay, someone, so like story from the real life that someone dead and from the COVID, and the like nurses getting new bed for me, like get this dead man, put his into the packet, and okay, so this is place for you. Okay, you can get here, so free free bed for you. Or it's like, okay, not bad. It's like COVID in my country. But yeah, that was like a nice experience for me. It was like I was completely like in a like almost like a dark blue color, everything, because I was like on saturation. My saturation was like 85, somewhere around like this, and this is not a like a low saturation, but it's kind of, so generally you have like 90, 97, 98, and somewhere around this. And when you have like 85, your hands, your like foods become like dark blue because they don't have enough oxygen in your veins. And so it was like, what's happening with my hands? It was not funny because I guessed this exactly on this day when I was like, I can't commit into GitHub. I thought that I'm gonna die completely, because it was like I was thinking like, what the fuck? COVID, Valerie, how you could get into this shit? Why? And it was like, okay, so there are no some kind of you can't have a pill because there are no pills from COVID these times, and only the thing you have like a sugar to your hand, like they have a nail and get me some kind of sugar, I don't know, thing like water with sugar, I think so. And it was like, okay, so it's not so fun. It's like 400 like 40 temperature every day for the 5 days, and I thought that okay, this is the end of my journey, because I had a special thing from the COVID called I don't know, when your immunity system start attacking itself, like, and like generally 80% of people who get in this situation died. Like, it's very rare case when your immunity is like a strong and it tries to kill all of this COVID thing and started and loses and I don't know, this virus between the attack and the information which comes back after attack. So this thing was lost, and so immunity system like just started to kill itself. And in this case, doctors should get you a special drug. I don't know like specific name of this drug, but it's like something which turns off completely your immunity system. Like, it's just tuning it off. Like anything basically like a cold can kill you during this period. And I'm stayed in a room. It's not like a single room for me. It's like 1, 2, 3, 4, 5 people at the same time was with me in COVID, and with COVID. I'm sorry. And it was like, if I get a cold during this immunity system turned off, so it's just easy way to die. So it's like done. Yeah, and that was like 4 or 5 days. I didn't sleep. I had a 40 degrees temperature, and imagine your bed is like wet, and you just can't do anything. You just sitting, laying on your bed. It's like and you're completely wet. Pelmeni. Oh yeah, so my wife also get easiest form of the COVID, but she lost the feelings. I'm sorry, feelings. She can smell things, and yeah, the same as yours. I get so my lottery, my COVID lottery. So after the COVID, you've got some, I don't know, some disaster, something which you get like low temperature, or lost your smell, or taste and smell, or I've got a panic attacks. So imagine you like sitting, and you are thinking that you in the next second you're going to die. Like, you'll die exactly next second, and you get a panic, and you need to run, just need to run. So you need to run in any direction, but need to run. And I'm just like, okay, this is only panic attack, this is, everything is fine. It was so hard to beat the thing, but I just, okay, this is just panic attack. You can just sit, just take in your hands, and everything will be good. So, and I break all of the thing very, very quickly, listening to my errors. Yeah, might be. So COVID is I don't know, it's not very fun to get, especially when I was in country where I come from. Health, yeah, definitely health casino. Especially in the country I were from. So it's it's completely they are completely missed any preparations for the COVID. So it's impossible to live, to survive, I guess. Okay, that was fun, but not as fun as Rust. So okay, for the STD out, I think we have to get so we have to get also a select. So we have a select in Go, And let me just move all of this. We can't use take and std out here. We only need to have oh, by the way, Julian, I'm going to completely switch to I'm sorry, to Vim on Monday. So this is a planned date for the switch. So funny times. So I need to configure it on Monday, and yeah, on the stream I'm sorry, on the stream I'm going to configure it and switch completely. So std out. So I feel like the Vim police. You're welcome. Like, you know, every Vim users, it's like a groups of Vim users, so you can't get into the club. Oh. Yeah, when I switched to my Moonlander, I was super unproductive for, I guess, 2 weeks. It's so uncomfortable when you're shifting on a split keyboard like this. So this feels super uncomfortable. But after 2 weeks, it will be super comfortable. I'm just feeling myself super uncomfortable with like a solid keyboard, like on laptop, for example. Child, oh yeah, mutable. And yeah, so yeah, this is just a habit. So for example, I have Z, and if I press Z for a long time, this is a control. Yeah, shift also. I have dedicated keys for the shift, for example, but for the control, alt, Vin keys, switching keyboard layout, I have like switching keyboard layout, especially language or like layouts itself. So I also have like keys which I have to press for a second, for example. You'll afford this, definitely. Just let it like let the keyboard shine. It takes some time when you switch into this type of keyboard. Yeah. First, at first like week, I just thought why I did this, why I bought this super expensive keyboard, super like split it, and because I feeling so uncomfortable with this. But later with I have a like carpet kennel syndrome with my previous keyboard, but now this is super peaceful to my hands. So I have so this is like I have my hands in like a natural position, not like this, like so I have like hands in a natural position, and if I want to like move them like one these halves of the keyboard, this is super comfortable. So I don't need to have them like synchronously in one solid block. yeah. So at the first time I had 2 keyboards connected to my PC. So one to type passwords and split it to just type. And I also have a solid keyboard for some time to answer on a question in the chats, because this is super uncomfortable to type, and I have to use to answer quickly. I have to use this like general keyboard, like a solid one. But then it would be super fun. I promise you, it will be super fun. Just let the keyboard shine. Let it take like 2 weeks, and it would be super fun. I also used this resource, monkey type. So to type. Yeah, so you can connect the second keyboard, and and if you need to answer quickly in the chat, so do not hesitate yourself to do this with like a simple, with like a one-yellow keyboard, as it says. Yeah. Option. Oh. We don't need to use like this. What is the tabs? Oh, it's. Oh, take and expect. Can't get std out. And child here. Child std out. Yeah, nice. Nice. Now it's fine. It's completely not the problem. We are just talking here. It's a stream. It's not. It's social event. You know. It's not something where I can like have a deadlines to work on or something. You know. We're just talking. It's. I think it's a nice thing to collaborate with other people and to talk and. Learn to type faster. Click to activate. Okay. Lear. I can delete. Why? Oh. So this is I guess this is super stupid to write on this kind of emulators, because I'll explain you. I have I can't remember, but on YouTube one guy designed a system to write actual code. So you get a random file from the Linux kernel, and you are typing the real file, real code. And this is a super smart, I guess, especially for the programmers, like to type faster, because you have a lot of these square brackets, like pointers, I don't know, so special symbols in your code, like ampersand, arrows, like this, and so this is a super cool project. Let me find this. YouTube Norway programmer live vlog. Yeah, this is it. You can you can have a look at this channel, and this guy wrote. Let me see. So as you may see, I watched a lot of videos. So this is super fun. Released app. ChatGPT 4. No. Apple should fire some people, for sure. They already did this. oh, okay, so you can try to find but this video on his channel, and he developed an application which like you can like write an actual code, you know. So might be to learn. Yeah, this is fine. I'm sorry, this is not as stupid as I mentioned before. It's like I guess this is fun because I'm also used a Monkey Coder, this site. I just wanted to say that you have a better project nowadays to type actual code. Yeah, like, but you're right. It might be after you start like writing actually, not thinking before you write. So we're going to delete all of these cells. Yeah. Okay, so Houston have a problem. Thank you very much, Rust. So the problem is the following. Yeah, as you may see here,
How do you want to do that?
this is our std out. Std out. Dun, dun, dun. And inside the std out, we are reading the data, yeah, and we have to kill the process. We have to kill the process in one particular case. If we have a trash in the output. So if we have a trash, we have to kill a process. But we can't do this since we are going to wait on our child. Yeah, we are going to use this like this. We're going to wait on it. By the way, do they have a kill? Dot kill. Yeah, they do. And how do they use this? Clean up. Yeah, clean up before exit. So definitely have to design. So I'm trying to design this in a way, slightly in a way I'm using this in Go, but I like faced already 4 times with the issue that we can't do this like we're doing this in Go. Like we can't kill the process here. Because so to kill the process, we have to get a child inside our thread here, and if we are not going to return from this thread, yeah. So we're going to return from it only if the worker dies, and if worker dies. Yeah, how we are going to return this from this thread if worker died? Basically, I guess we are going to return from one of these functions like read exec, and we are going to return on this question mark, yeah, with some error. We also, yeah, I guess we also need to start a thread with the handles with this for these threads. Let handle and like have a result from this thread, yeah. But actually we also have to kill somehow the process after this duration, after 2 seconds. And for sure we can introduce another one channel and like send a signal to this channel and have some loop, but this looks to me super complicated. It's not so complicated from terms of understanding like the code, but it looks like super complicated from the terms of where you like overbloating the simple logic, you know. So Rust safety rules. In Go, the problem also with this thing, with the kill especially, yeah, that kill child command kill, yeah, this is mutable reference, as you may see here. So, and we need to have two commands and two methods, two mutable methods, kill and wait. And while we're waiting, yeah, so I don't think it's even possible without an extra channel. But also think about this: if we have a wait, yeah, so wait holding a mutable reference to this command, yeah, and if we write a thread and move this command to the thread with this channel which waiting for the signal, we are going to have a mutable reference to this inside and move this into the thread like this. We move this mutable reference, and we can't use it outside in any way anymore. But we have to kill this process because this is indicating for us like that it violates our rules here. We should do something with it. We can use unsafe here. Okay, so for sure we can use unsafe, and we can use like some kind of syscall like send syscall and ID like a process ID. But this line will bring to us an unsafe. Yeah. ancient knowledge, yeah. So lost somewhere in Egypt. So I don't think that this is even so. And if we introduce like this system calls like this, we also, why not to use pipe2 system call to pipe the actual pipes? And this is like silly road, you know. This is not the road where we wanted to go, actually. And how to do this? And this is like how this is how like hard to prototype in Rust. So prototyping in Rust is impossible, I guess. Like it's just not possible to do. So you can do this in Rust, like period. So you have to prototype in a Python, in PHP, in Go, but not in Rust, because it's like any rule violation, and you like kicked out from the profession. So how to kill this process? Okay, let's think a little bit broader. How we can read? Can we do the following? Can we read the data and send it to another channel? Oh no, it's like too many channels. What if we use here on our child atomic reference counter? Would it be fine to Rust to accept this rule? I don't know actually. So like this. Where does it have this? So use an shared shell like this. If we use an atomic reference counter on it, let's try. Let share child is equal to atomic reference counter new, but at the end it looks like super safe, like ultra safe. And here we use a command. And then here we're going to use like this. Let child with underscore, like the super Tauri devs do. It's like child, our shared child clone, and child like kill, like this. Can you make child mutable? Sure, no problem. Okay, so receive std out. Let me like just completely. So this is like completely destroying all of our like forces to what we already did and already released under the super stable 0.1 release. Yeah, and then move. And so in this case, let me fix all of this. What? It's not a child actually. It's std out. This is. Oh, we don't need to actually use this because why we need to? And here our command would be not a command, but arc child like this. And since our command share child clone like this, and what you gonna say us? Cannot borrow as mutable. Rust, please stop. Cargo build. Move. Oh, I didn't use move? Oh, yeah, so for sure we should use move. We don't need a handle. std out. Oh. Why? Oh, yeah, so command and this point like this. We should take it out and this before we make an shared reference. Okay, std channel. Like completely, we are completely destroying all of our code. Okay, ID, we don't need it. ID here, bye bye. And okay, so still have an error. Command borrow arc is mutable. Required modified derivative, but it's not implemented. We need to dereference it, yeah? I can't borrow data is as mutable. Help remove this mute, so it's like, okay. We can do this, I guess. Because this is just a reference, but we need a mutable reference. Like, when people say that you are gonna definitely fight with the compiler, how this is definitely how it's look like. Fighting with a compiler. It's like a war. No, I don't want to get this road. Because why to use Rust if you use intermutability? So yeah, in some cases it will be fine to use it, but I want to avoid this as much as I can. I don't want to use intermutability, mostly because it's like this is like a slightly Rust rules violation, you know. And this approach lead you to use Go. Do you want to become a Go programmer? I think no. So as we see here by these changes, like this is, I guess, attempt number 4 to write in this API in Rust. Like, we did this previously. It's like super clean, super shiny. It's like, mwah, super cool. But then, oh, we need to wait a process. Okay, so we need to wait a process. Oh my God, this is you can borrow these two mutable references. You can't have them. Yeah, this is time for the rewrite. And here so we can't avoid this. So we just can't. We have to kill this process. So there is no other options. There are no other options. We should kill it. Oh, I guess. Let me check. Child. Oh, this is child, like, okay. Cannot borrow arg is as mutable. You can do this for sure. As ref, as mute, we don't have this. Okay. Tauri, save us. What does it do? Like share child clone. And they use it only in one place. Like, why? Oh, they use this child. Okay. Yeah, so I was wrong. They use the like a parent of this child. And the shared child, what is the shared child? Oh, this is... This is... core. Do they have their own runtime? I don't think so. So if we comment this, let me just double check that we don't have any other errors here. Yeah, so as you may see, everything's right. How to bypass this rule? So what options do we have? We have a shared child, yeah. So our shared child is should be used only. So we need only two operations on our shared child. First is to wait for the process to exit, and second one is to kill it, yeah. And how we can do this simultaneously? So do we use commands? No, we don't. Maybe we need also use like here before we actually use any other API. No. Oh, can't find yeah. So atomic reference counter. Thread safe reference counting pointers. Allocated in the heap. Sheet references in Rust disallow mutation by default, and arg is no exception. You cannot generally obtain a mutable reference to something inside an arg. If you need to mutate through arg, use mutex read. Oh. But if I use mutex, so if I use mutex, I'll log for like indefinite amount of time, you know. So if I use a log here, and so it's fine to use log on this function, yeah, because it's just I just log unlock, and this is fine. But on wait, I'll unlock for the long time. So I can't use read logs here since this is immutable references, you know. If they were immutable references, yeah, this is fine to use read logs here, since the references are immutable actually. But this is immutable references, so kill and wait, and those we are going to use. We force it to use like logs here, and read write log the guys use, yeah. Commands log unwrap insert guards. And as you may see here, these guys don't use any like any logs before the wait, yeah. Only after it. And I don't see here if they use anything related to kill. Might be signal. Maybe we have to use something like signal. What is signal? If the process was terminated by a signal, represent that signal. Terminated payload. This is not that I want to see. Yeah, it's like arg mutex. Yeah, so I guess this is not a problem to try. Let me just check. But you know, this is not something like I don't like to see. So Rust is a, I don't know, special, like so special programming language that you are not like super upset of using of having these issues. For example, this is fine that we have this issue, and we are just trying to make the API better. You know? Yeah. Yeah, exactly. So in Go, for example, you won't have these errors. And you're like, okay, everything is fine, everything is shiny and like pony jumping around you. But on the production day, you would have a super crash, for example, if you improperly test your code on race conditions. Boom. But Rust, so specifically for me, I'm excited to have these errors, because these errors leads me and you guys to an experience how to handle these cases. Actually, you know, how to understand like how Rust think here. To write in Rust, you have to understand. You have to be a Rust like. Yeah, so we can't, and this forces to us, like, I guess, okay, I'm not so super experienced in Rust, and what I see here that Rust tells me, like, okay, your API is a trash. You designed and trashy API actually. You have to redesign it like 10 times, 20 times, 100 times, but at the end you would have like brilliant API. And killing this child, how we can yeah, this is super cool. Yeah, I agree with you, Georgine. And especially for the Rust, this, so okay, let's think. Okay, let's leave it. Let's leave this error and think how we can design this API in different way. We have to kill the children. Okay, we have to do this because at this point, we are okay. Oh, my teeth. We can return for this from this thread actually, yeah, and we can kill this after we return. Yeah, so since we don't need any data in this thread anymore, yeah, we don't need to continue this. And moreover, so we are killing this child here just to exit from this where is it, read to end, yeah. So but as we did previously, server history, where's our frame, commands mod, yeah, as we see here, we use this timeout, yeah, and asynchronous function. We can exit from this loop actually without killing the process, yeah. Only one thing we need to do is to exit from the process. And if we exited from the process, at this point we should somehow notify ourselves that okay, this process is not like healthy now. We need to kill it, but outside of the thread. without starting another thread. We can actually have I don't know, some kind of blocking mechanism, and we need to use wait also. Basically, we are killing this process here just to exit from this line, because we with read to end, we are going to block for like unspecified amount of time, you know. Let's do the following. Let's get our actual Tokyo code, like this one, asynchronous, and like this one, and try to apply it. We do need a thread here. Yeah, we do need a thread. Okay, so how we can... Okay, after we... after we exit from it. Okay, child, let me just apply all of this. Child to move to here. Should be fine now. And wait. Yeah, and we are going to use here not thread spawn, but we are going to use Tokyo task here. Tokyo task. Let me just check the documentation very quickly. Tokyo task. Oh, task spawn. Tokyo task spawn. Yeah. And async for sure. And we will be able to use async, okay? And also we do have yeah, join handle also. We should have is not help try is not limited for the pipe. Yeah, so we also have to use asynchronous versions of these buffers inside this. And we do need to remove all of this kind of shit. And we don't need to... Yeah, we don't need to return this OK frame. We are going to std out sender send and a frame like this, so we don't need to use it. Okay. And let's see to the errors. Actually, we can't use buffer here. We should use all of so all of the buffers should be used here is should be used from the Tokyo. And we already like have this buffers. It's like this one. And for sure we also have to use a command. So everything we should replace the standard API with a Tokyo API. Basically, we don't need a duration, a thread. We need the channels. We don't need the process and stdio IO, and replace it with the Tokyo versions of it. And yeah, stdio. We need this one command from Tokyo. Yeah, correct. And thread spawn, we also can use Tokyo task spawn. And since we are going to use this, so a lot of errors. Async and child stdin, we have to receive await. I guess we should have oh no, as this is like our channels. No, we don't need anything here. We only need to have a child. Since our child is Tokyo child, yeah, we need to child, I guess, write all await like this. And what else you need? It's not a future. What is not a future? Child or what? So let's first of all deal with a first problem and comment second one. Tokyo, yeah. Yeah. Tokyo. Must implement into future to be awaited. Okay, Tokyo spawn. Let's see the documentation. Not available. What? Tokyo? This is a joke. Async. We don't need a blocking thing. Okay, so what you... So now, without anything, is this fine for you? Still not. Oh, yeah, this is, I guess, Tokyo... Yeah, so Tokyo task uses only like async and this, yeah, like this, without this vertical lines. Okay, it's better now. And what we're arguing for? Await can only be applied in a async block. There is no other option. So we have an async block. Async. Do you see this? Async. Rust, please help me with the error message. An async block that returns. Oh my god. So we should use expect. On what? I'm gonna get yeah. So futures are awesome actually, but so in Rust this, so actually when you are on a programming like interview, if you I used previously C#, yeah, yeah, it's not very obvious, but the real case from the interview, you know, I was on an interview. I was interviewed for my like Go knowledge, yeah, you know, and I was exactly from like 2 months from C#, yeah, and I lied, said, okay, it's like a year. I'm already 1 year in Go, because it's the concepts of the language is very similar. You can answer actually on the C# questions, for example, with the Go somehow, yeah, and vice versa. Especially vice versa. When you like have a smaller, you don't have an OOP on all the things, you can actually answer on a like when you have a big experience in C#, you can answer a question in Go, having like 2-3 months of experience. But this, you can't do this with Rust. Like actually can't. In Rust, you have to have like year of the experience, of the real experience, to answer on questions like async move, futures, and all of this, etc thing, you know. Borrow checker, if you didn't like pass this way, having a lot of the errors of the like from the borrow checker, you just can't answer any question about the Rust on the interview. You just, because this is conceptually the language is too different from the others. Yeah. And now I think poop formatting. Can we use here yeah, so let me check the documentation. How I don't think that we can write anything here, or we can. Yeah, we can write these vertical lines if we have closures and we have a blocking function. Yeah, but that's it. Documentation is done. So do you mean that we can write something like this? No. Yeah, we can do this. Or you want to write so why I can't use an operation like this? The operation can use a single block that returns result on option or another type that depends from residual. Oh, like this, do you mean like? Oh, might be you mean that we are going to write future and then pass future here inside this block, like instead of doing this. Like this. Let foot is async and but how? Oh, so I need. Oh, yeah. So I. I need to like scroll. Yeah, I know this, but so cannot infer type. So basically we are doing this and the explicit type annotation needed. Trubafish, hello. So, can only be used in async blocks that returns result or option. Okay, another thing. Rust Tokyo result. So do they use? Yeah. So that only solving the problems letting use this question mark. Async planning, yeah. Blocking and yielding. I don't need to block. Working with the tasks. We don't need a blocking. And they use only this, you know. They don't use oh. But this is not an inside. Okay, oh, they also have this sample, similar sample from the quotation. Wait. Okay. But in this case, how the hell I get sync MPC. Okay, can I use like this? Like, let's start writing line by line, like the Rust way. Yeah, only problem. Yeah, you're right. But this one, non-binding led to a future. Consider waiting. Okay. Oh, give me a second. So std in, as far as I understand, also as a future, no? No, it's not a future. This is also not a future, and we are. I'm sorry. Non-binding led to a future. Okay. And child. Write all. Just experimenting. Write all. Provide an argument. Okay, I already did this. And await. Can't use this. Await. We are not waiting for a future. Only with unwrap. Non-binding led to a future. I expect this can be built. Yeah. Let me remove this super big type. Okay, so if we can use unwrap, but actually I want to use expect, since foo. But why it's like, okay, this is not being led to a future. Consider awaiting the future or dropping. Oh, this is join handle. IF await like this. Oh, async function. Oh yeah, so first of all we have to await function, so our original function should be async for sure. And we can convert the error to error. So we also this is not a problem. We just need to implement from for our type, but this is actually we can use just unwrap. It's not a problem. At this point, we're going to update this, but this is not actual problem. No, at the moment. Okay, so we can use like this. Now we are deleting this and using this. And let's try to Google it. Yeah. Do you mean this? I mean, workaround. Like this? Am I right? Okay, let's use it. And okay, and let's use std.io like this, because we have an IO from like this. Futures cannot be sent between threads safely. Future created by a sync block is not sent. Receiver. Tokyo channels. Oh, they use this await. Without this, like this. One shot. Tokyo Sync. Oh, they also have their channels. Okay, let's try to use them instead of standard one. STD. Sender from the Tokyo, I guess this one, Tokyo MPC sync. Yeah, guess this is the correct one. Tokyo, yeah, this one. And here we would have mutable. Oh, they have oh, capacity. Go, is it you? Like this definitely like get from the Go. Expect a packet type. What? Yeah. Yeah, outbound channel. Yeah, so this is not problem to use this buffer channel, like Golang channel. I actually don't know why. So why do you have the channel buffered? But okay, so let's have this frame. But receive also await should be like used as a synchronous function. And what is the type actually here? We can do this, yeah. Because, yeah, we can do this. It's much types. Expected type frame, found time result. Okay. Frame. Oh, yeah. I should delete, okay. Option frame. Okay. Frame. Let's do if let some like let me call this data. Frame is equal to data. Okay. No. Frame mutable. Yeah. Forgot this. Okay. Now this might be. Yeah. Now this compiles. I don't think it will work. Irrefutable while let pattern. This pattern will always smash, so the loop will never exit. Yeah, the loop will never exit. This is what we wanted to achieve here. And at this point, oh yeah, expect. Yeah, so sure. And let me add expect here, like can't receive data from the std in, like this. And yeah, at this point frame would be actually yeah, so we don't need this. Frame and like this. Yeah, I know that we're not going to return from this, but this is fine for us. Okay, so we won this little battle. You probably don't need to return workaround anymore if you don't need the yeah, let me delete this. But I want to return this work to do like this. But in this case, yeah, so I can't. So they just accept only like empty option. So this Tokyo spawn function, join handle output. What is the output? Oh, this is only a future, like poll select. Yeah. And basically, as far as I understand, we just can't use this in a Tokyo task. So Tokyo task, this is definitely like a Go routine. This is like one-to-one copy, because Go also inside the Go routine, you can have a function which returns something, but in Go, the like conventional way to work with the values which can be returned from Go routine is a channel. So you can do like this, and so do you mean I can now remove this? Yeah. And why are you arguing here? Yeah, I know this. But actually inside a thread, like a big one, you can return some data. Yeah. Oh my god, this is so when you are not, so this is so hard for me, because I'm like, I know that I know Golang very well, and when some programming language super good like Go, this is so hard to realize that you are writing like 10 lines of code in different programming language, especially Rust, so long time. You're fighting with like every line of the code, like it's exactly after the war. Like you're fighting so for every line. Actually, this is very hard to realize. Actually, okay. So we are going to. Okay, let's see how we can return from this while let std to frame. We can actually drop it, and in this case, we're going to receive this error message. Yeah. So how we're going to exit from all of this kind of tasks? So we should have. So how I can do this in Go? I'll like use a select in every task, and use a channel which I can like send a value to a channel, and if I get this value, so I can return from actual task. I just use the return. But so this is valid for this function, yeah. But let me uncomment this one, and yeah, remove this, and use this. Await. Yeah, expected enum result. Okay, so let's start from the beginning. Let's start uncommenting this code line by line. So only valid only in Rust, you know, to do this. Okay, this line is fine. This is also fine. Here we are forming headers. Read only 12 bytes. Read exact. Await, expect. Failed to read here. Tower Mind, thanks for following and enjoy the stream. And welcome. We have an options yeah. What? Again? So we had a disconnect, and I guess we are already back. Oh. Linux, please stop. Don't do this. Don't do this. So suddenly we had a disconnect, like it's back, like we had previously. So it's like our flashbacks. So the problem is, I guess it's some kind of I don't know. It's like might be the router sent some like busy frame to the to my card, and it was disassociated. I don't know. But so when I switched to VPA 3, so I didn't had any issues with the Wi-Fi anymore, like, you know. So VPA 3 was like a solution to my error. Okay. Let's continue since all issues are resolved. Okay. So the problem is here. Await and expect failed to kill the process. And yeah, here you are. So we are returning the error. Yeah, this is another one problem with this task. Oh my god. So yeah, so I guess the problem is that Tokyo task actually is similar to the Goroutine, the Golan's Goroutine. And inside the Golang Goroutine, you can't return anything except because this is not a real thread. This is as they say it in their documentation. Where is the documentation? Yeah. So this is a lightweight non-blocking unit of execution. This is not is similar to an OS thread, but rather than being managed by the OS scheduler, they are managed by the Tokyo runtime. So exactly like so green threads and Goroutines, Kotlin coroutines, or Lang's processes. I don't know what is this and Kotlin coroutines, but I know what is Go's Goroutine. So basically, Go on Goroutine, you can't return anything from the Goroutine. Only you can do this only using the channel. Yeah, you can use a Tokyo thread not a Tokyo like task spawn. I just want to. So see, the problem here is in the following. First of all, definitely need to check this. But I guess this is pretty much the same as a Golang routine. So if you want to return something from this task, you have to use a channel. Like that's it, simple. Simple. So, I'm sorry, Rust. I'm not treating you as a simple programming language. So, and the problem here is, so we have to not to return, but we have to use a channel stdout sender stdout tx send, and send here this message actually. Await, expect, failed to send the message. Oh, send is, this is not the frame. This is not the frame. Yeah, this is string, and string, but not as, so yeah. Yeah, so if you use if you are going to use a function like this, like I used previously, like here when we are receiving str, so this is definitely possible to return anything, like basically. So I also wrote an like from, and I'll be able to like convert from this type of errors to the my actual type, which I use in Gorish. So this is definitely possible, but if this is also possible in thread, but this is not possible, I guess, in this. So I'm not guessing. So this is for sure. We proved this theorem that this is not possible to return anything from the Tokyo task. And this is fine, since we are not going to return anything from it. So I'm not going to return the data from the Tokyo task. I'm only needed to use inside a channel, so like in Go, yeah. So I don't need to return this error actually. So, and the last part for us is to okay, so yeah, we can't do this. Another problem. So we can't. So we here we are not having a frame. At this point, we have only the string, yeah. But in this case, we have to return error, you know. We have to return an error here. But error here represented as a string. It's not an actual error. It's only like notification for the users that something going wrong. Yeah. But actually, if everything is fine and we don't have this verification error, we're going to send a frame back, but not a string. And I guess so how we can avoid this. So we can just write implement to string for a frame and use like into, yeah? Or like implement to string into string, for example, for this verify and send the frame, but actually send like somehow string representation of frame, which will contain this error, and how user. No, this is not possible to do. how user will determine, or especially how I determine when I start reading from these channels that this is error. I don't want to check a bits of this protocol, so for example error bit for every message. So this is kind of fast, but I just don't want to like do this. So this is unbelievable. How we can, so let's start from the beginning. We can do this way. Let's start from the beginning actually. So the attempt number 5. First of all, let's determine our task and then split this task to the subtask what color head. So you can choose it. So we have these colors, and I guess, do we have yeah, this is kind of important question. You can like choose the correct one or provide me a code. I can do basically anything with any color. So this is up to you to choose a color of the head. Now I'll just write this attempt number 5. No. Attempt number 5. So red hat failed. So red hat failed. Yellow hat failed. So you wanted, I guess this is a rusty color. Yeah, you're right. Let me check my guess. Okay, purple. let it be purple. Okay, you got me. So shade of pink. So I yeah, this is a pink. Yeah, for sure. Okay, we have a man. So let me write it here. Pink hat. By GJ. Okay. So this is like additions of the windows, you know, code names of our rewrites. So let's determine our task one more time. We have a process, yeah? PHP. Inside our process is PHP script. We communicate with this process, so we can have a lot of them. So not only one. We call them workers, yeah. And we communicate with these processes via via pipes. We can also communicate with them via like Unix sockets and TCP in Go, but actually in Rust, I'm going to use only pipes. Yeah. Okay, so we have 3 file descriptors: in, out, and error. Yeah. So within this is so we have to, for each of these channels we have to support 2 types of the operations. First type for the in, for example, is to send data, and second operation is terminate. Okay, so for the out, we should be able to receive the data and to terminate. Okay, and for the error, we should be able also to receive, and for sure to terminate. We don't need to communicate with std_error. So std_error is in our sample here is kind of similar to the std_in, because std_error we only need to, so from the std_in perspective, we only need to like send the data. So this is kind of simple loop, you know. Speaking about std_error, we only want to receive the data. So this is also quite simple, and we don't have. We also have. I'm sorry, guys. We also have a frames, so all of the data transferred from all of this kind of pipes should be in the frames. Frame, frame, and frame. So these are our frames. Yeah. Okay. So this is the requirements. Yeah. So what we should support. Next thing, we should support basically two important operations. We should be able to wait the process, exit. We need wait the process exit because imagine if we have a worker and OOM killer decided to kill this worker. So and it kills it, and we need to so after we exit from the wait, we need to determine who did this. Who did this? And if it's not our code kill this worker, we determine this by the states. For example, if we have a state destroyed, and the state destroyed indicated that this is our code destroyed this process. This is quite easy to actually do, but yeah. So wait, we should wait it, and if the OOM killer killed our worker, we should be able to restore it. We should be able to restart the process, re-add the process into the let's say vector of the all of the workers, and etc. etc. And second, very important operation, we should be able to kill our processes. So why we should be able to do this? For example, if we are receiving the data as I shown in a previous example in our std_out work, imagine we received a trash, like a trashy data. So this is not our frame. So we received a trash. So we can actually receive a trash. We can't send trash to the actual worker because we are like controlling this send operation, and we also can receive a trash from the std_error. So two types of receivers. And if we receive trash, we should be able to kill this process, because if the process starts to send in the trash to us, this is the indicator of some kind of failure inside the process. Yeah, because PHP won't send us like incorrect frame by purpose, you know, only with error. Even if PHP fails with exception, this exception should be handled by our worker and pack all of this data into our frame. So impossibility to pack this frame into this data into the frame indicate to us that okay, so this worker is ill, possible COVID, so we have to kill it. And wait operation is important for us to know, because we can kill the worker from basically from any place of the application. So basically in Golang, in our RoadRunner actual application, we have a shared mutable reference. So we are allowed to do this in Go. And we check this reference from a lot of places, but this reference is protected by mutexes, but still we have this shared mutable reference. So we have to support these two operations. Next thing, the problems with the implementation. Problems. First of all, wait and kill both are mutable references. And we can't have two mutable references at the same time. You know, this is violating Rust rules. We can't actually wait and another thread trying to kill the worker. So we have to design some kind of use, or for example ARC to protect, like, let me write like this. Like to use ARC, for example, with mutex inside it. Yeah, something like this. I'm not sure if it works, but we're going to use this, some kind of this approach. And this actually can ruin all of our efforts, like to write this good looking API. Yeah. Why it can ruin everything? Because if it's not possible in general to achieve by any Rust constructions like interior mutability patterns and etc., we just can't re-implement what we want to do, what we want to have. I'm sorry. And yeah, okay, let's try to think what methods we need here. We need a method called new. Yeah, for sure. New is going to allocate the actual command, actual process. So new receive an string. I'm sorry, slice of the strings. Slice of the strings is actually our command, like PHP, then like worker .php, like this. So this is actually our list of the commands. Yeah. Do we need to start a processes inside this? Yeah. So on an iteration number 5. Yeah. I'm sorry. Yeah, so I expected that pink head would be the last iteration when I actually start to like implement this with unsafe. So this is the last, I guess, our safe effort to implement this. We can do basically whatever we want to do. So we can implement this API in any way we want. Yeah, actually. So our problem here is we should have these operations and these operations at the same time. Yeah. So let me think. Okay, so new. We definitely should start a command here in the new. Yeah. Let me just do like this. So bum. Like this, starting from just from 0. Okay, we don't have anything. So cargo build. Nice, it builds. Finally. Okay, So it works. That's it. Yeah. So we also can. I just don't want to delete the tests because they are actually correct to like from the point of view. I just don't want to like rewrite all the things. So, but we can do like this. Okay, so new function. Rest in peace. Yeah. Function new. What we want to have. Let me think also about the pipes. Async pub fn. Let's say, so we should be able to support 3 basic operations. Support 3 operations. Oh, we can use Obsidian actually. To dev nodes. Okay, let's create a new node and call it Gorich RS. So API, yeah. We should have a new function which are going to return result. Yeah. We should have. So ideally, we can't solve our task using threads and channels. Yeah, because if we use channels, we can't use 2 operations at the same time, like wait and a kill. Yeah. So we have to include all operations into. So basically, we can use we can wait, yeah, but we can use for the kill some kind of unsafe API, yeah, by PID. So since we know PID of the process, we can just kill it. So this is not a problem, I guess, to kill a process. The problem here comes from when we are trying to wait and kill at the same time. Okay, so let's think. We also have send std, which is also should be like async, which is returned to us basically, I guess, only result. Yeah, and we receive here frame. And this function have to be mutable. So it have to be mutable if we want to use here our std child, because child is mutable by its nature, and to use it inside our function, we also should have this function mutable. Yeah. We should have async receive std out. And this function is also should be mutable, and result should be of type of okay, like frame and error. Here is just empty and error, like this. And the last operation should be done via the channel. So actually we don't need this operation to like read data from the std error, actually, you know, because std error is not important for us. We can just start a thread, like take an option, start a thread, and just read it indefinitely, like until we kill it. So it's definitely so super unimportant part of this hours API. So if this 2 function works fine, this is actually like 99% what we need to have. So because adding std error reader to them is like super easy. So we don't need this. But actually, let's let it be here, because if we realize it std_error break everything. So yeah, so let it be in this way. Let it be in the new plus read std_error. We also should have like a configured logger and etc. But we can pass the logger here, for example, logger, and like send the data into this logger in a thread, like copy it and send, or use like macros like debug, info, and etc. So users should be able to configure this, and so this is not a big problem. Okay, to configure actually, and we should have so, and this is a question marks. What about async kill? And it also should be mutable, because kill function from the process perspective is mutable. We actually don't need to return anything, because it's like, so just dead process. And here we should decide how to go with this. First option, use unsafe, and use unsafe, and this leads to us to use like libc kill process, like, yeah. The second option here is to use star, like this approach, like kill children's. I don't know, they just add this children's at the end. So this cleanup, actually we don't need this cleanup before exit, because if we wanted to exit, this is very easy to implement this cleanup, yeah. And where is it? Oh, it's inside the comments. The second approach, first of all, we might also use an where is this? A pipe. What? Clipboard. Where is it? Yeah, pipe. So if we go with this unsafe approach, we can also use a pipe here. A pipe here, but a pipe connected to our parent process. So how? Yeah, they just send from the parent process. Yeah, they send from the parent process to this. Yeah, so we can use in this case these pipes, but actually, so we should be able, might be, to have this approach. Yeah, as you can see here, so as you guys can see here, this is super cool approach, and this is all not blocking here. std_out reader, std_error reader, and they don't have an std_in, but they don't have anything to send. But actually, so this spawn, what is a spawn actually? This is not an async function. Oh, this is not an async. Wait, what? This is just a function. Oh. But what is this one? Oh, send plus copy plus static. Oh, they use static lifetimes here. Oh, but yeah, this is, I guess the guy from the past stream was right. This is not what we actually want to have, because static here will bind us to hello. So here RPS. So so scary. Yeah, like C++ might be. So this is not. I don't think this is super scary, but I guess it's unfamiliar slightly to the like another other programming languages. Yeah, Rust is a lot scarier. Yeah, Georgian. Yeah, you're right. So this is like our fifth approach to write this API in Rust, and yeah, this is syntax is actually not a problem. Actually, super actually. Okay, so we can't use this. I lost. Yeah, we can't use this because first of all, static. Our workers are not like don't have a static lifetime. Yeah, we can't use this approach. Closing this. So this is. As Rust minus minus. Yeah, Rust minus minus. Might be. You're right. Okay. C++ is Rust minus minus. Yeah, so you're right, but it's like not Rust minus minus. It's Rust like Rust minus 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 minus, like 10 minuses. So if we want to have an unsafe, so using actually libc will force us to use a platform-specific API, because libc works for the, like, I guess it works for the Linux. I'm sure that it works for the Linux, but I'm guessing that it should work also for the Mac and for the Windows. We also should have I don't know how this function called in Windows, like win32 kill might be something like this. We should have a platform dependent API. This is not good actually, and this will bring us an unsafe function. And so we have to write wrappers over this unsafe function to use it safely. For example, here we are not be able to use mute self. It was just like ID u32, and it would be like a save function, and this wrapper should be unsafe, and this function should be safe. Like, so we will build a lot of the abstractions, but this is fine. To do this, if we wanted to use this kill. And actually, this is the only one problem for us. If we wanted to have everything asynchronous. Okay, and the last one is async wait function. And inside a wait, we should be able actually to recreate the worker, process. We should be able to determine the reason of death. We should be able to clean up resources allocated by this process in our app. I guess that's it actually, so we don't need to do much here. So we in Go we're just removing it, setting the state, checking the state actually, so to if we have a destroyed state, so it killed by us and it should not be reallocated anymore, we are allocating a new worker and sending an event into the event bus. Actually, really we don't need to do this in the Rust application. So so basically it's like allocate and remove. and we should block on this function, you know. So another approach here in our kill function is to use save Rust and inspect the interior mutability pattern. This one, interior mutability Rust. Sometimes a type needs to be mutated while having multiple aliases. In Rust, this is achieved by using pattern. But I guess this is allowed to when you have two references, one of which is like immutable. So we don't need to actually mutate this data. We should be able to have an access to this field, to just kill it, because they are under the hood. They can do whatever they want, and I guess the problem would be, okay, so we only using, so what problems we can have if we use this interior mutability pattern. First of all, imagine a case. We have a mutable. We have std in and std out, which are bound to our child process. Yeah, and we are trying to kill it with this pattern having mutable reference to it, and at the same time we are waiting on it, waiting on the same data structure, to like on the same child to process to exit. In this case, I'm guessing. So in this case, we would have just some kind of weird return state, I guess. So we don't need to, but actually this doesn't matter to us. So we can have any like return state. We actually so it can be like any exit code. We just need to know what the state of the worker is. So it is if it's destroyed by us or by another like OOM killer, for example. Yeah, also it feels like to me as well. So it's like, but we should wait. So how actually this problem should be solved in Rust? So how this is? I don't think this is some kind of new problems, because you know, waiting for the process to exit is common thing. By the way, okay, so if we want to go the unsafe way, so this is like unsafe Rust, and this would be also like safe Rust. Okay, unsafe Rust for the async wait means, I'm sorry, that we can use a syscall wait pid, yeah? So this way we're not going to interact in any way with our resource. Actually, this is main wait pid. Yeah, so we just need to have a pid and a state. That's it. So state is int or u32 as far as I remember in Rust, and pit is just our pit. So this is unsafe, but this is the way how we can just wait for the process. Actually, Go under the hood uses this system call to wait the process. Yeah. So we can use unsafe Rust to achieve our goals, to kill and to wait. We can write as safe wrappers over these functions and use it in safe Rust. So this is basically two super basic functions, like kill and wait. This is super basic, super tested, and well-known approaches, for a lot of the programming languages. So Go is not an exclusion from this family, because in Go they use actually inside this wait, as you can see here, wait and wait and wait and wait and syscall 6 syswait id. Basically syswait id, we have two, wait pit and wait id. So this is, like as you may see here, this is also system call. But in Go we don't have but I think, yeah, so I think in Rust we also use this. Let me just double check this. In Rust they also use, I guess, system call under the hood, but where is it? Oh, this is nodes. Gorge command new, let me command wait, boom. So they also take, oh, this is Tokyo, yeah? Yeah. Source, process mode, register, GitHub. Yeah, this is Tokyo. Tokyo before, so in case of using Tokyo, coding hot tube stream. Yeah. Give me a second. Okay, so Tokyo in this yeah. So Tokyo in this case, closing the stdin, actually dropping the stdin, and in case of Tokyo we have to take this before Tokyo took this out of this self, yeah. Where is it? Okay, child wait. Fuse a child done. Where is the kill of the process? Only with drop. Fused child. Start kill. Like I'm slowly taking my pistol out of the pocket. Like start kill. Wait. Oh, start kill and wait. Yeah, this is fair. This is like a fairly good pattern. So okay, why not do this? Okay, start kill, and where's the kill actually? Kill is a start kill. How can I get into this? Child kill, inner kill. The end. Dead end. So they just, so without interacting with the system libraries, they just can't kill. So this is not possible. Just how? If they use their own runtime, they can like drop inside their own runtime. But if you're using a system process, you just should interact with the system to kill the process. So that's it. I guess this is they also use kill system call, and we can move this kill system call to the level, to the hours level, you know, here, and use unsafe Rust. And this is the only way, as far as I understand, that we can implement this, all of this kind of stuff. Wait, actually, since we don't care about actual exit status, we can use wait p to wait for our childs. By the way, it's not possible to wait for the other childs. So it's not possible to wait for the child allocated by different parent. To wait for the child from the different parent, you have to use super new system call introduced in Linux kernel 5.10, as far as I remember, called wait for PID. Wait for ID might be, or oh yeah, I have this PIDFD open, 434 system call number, and this is how I implemented this in Go. This is super ugly. Here, sock hid RPS, you can see what is the ugly code. Here you are. This is how I implemented the low-level code with Go. I don't like this, actually. So this is a lot of unsafe and syscalls. Yeah, in Rust it will look like, and for sure if error is not equal to nil. Yeah. So, and since let me see. So, intermutability here is a dead end. Yeah. So need to read about this. So I'm also thinking that intermutability here is like not what we're going to have. So the only way to do this in a good way is to use this unsafe Rust. This is so yeah. I after 5.4 rewrite of this API, I think this is the only way. This is the only way to make our. But in this case, we're going to have a platform-dependent API. I mean, not platform-dependent, but actually this is two basic functions. So we should only have like configuration for Windows, macOS, Linux, or basically all POSIX compliant systems. If you wanted to have, because wait PID, what's the difference between wait PID and wait for actually? So wait for is non-POSIX implementation, so it won't be supported on wait for syscall. Let me show you. Wait for. It have a BSD style. This is not POSIX compatible. Compatible things, but. Where is it? Main for wait for are similar to, but additionally to resource usage. These functions are non-standard. In the new programs, the use of wait p or wait ID, which is Go uses, is preferable. So we are going to use a preferable way. So this is a plan for our pink hat. Pink hat is a code name for the rewrite number 5 of our API in Rust way. So what we're going to do, we're going to implement safe wrappers to the unsafe functions. For the kill, we are going to have an ID, actually PID U32 receive to kill the some PID, yeah. And U32, actually to wait for a PID, we need to call only, we need to have only PID, yeah. Can you like send one which you like more? So yeah, as you may see, this is definitely a problem. So I don't think the Rust have a lot of the problems for the other types of like design API. Actually, we just have this particular case, hard case, I guess. We just learning Rust hard way. So I think we have OS pipe project to like OS this one. This also have like create pipe, like connecting the pipes, reader writer, like this. But this is not what we wanted to have. So this is command, and we might actually use this OS pipe, try to apply this approach. But still, OS pipe uses this is just a wrapper around the pipe system call, as far as I remember. Yeah, this is pipe. So this is only the pipe. Do pipe, yeah. So man, pipe 2, yeah. Create a pipe. Here you are. So this is the way. I guess the only way here is the unsafe way. A library for awaiting and kill child process from multiple threads. Type inside library wait and kill method that takes, oh my god, mute self, making it impossible to kill a child process while another thread is waiting on it. Exactly this is exactly our problem. The design works around race condition Unix. Yeah. This is also why Go uses this wait pid function, because this is produces race conditions, while a pid might get refused, and this is why Tokyo library actually drops the std in before they trying to kill the process. Wait for the process. Yeah. Whereas the pid get refused as soon as wait. Yeah. However, with the newer POSIX wait ID function, we can wait on a child without freeing its speed for reuse. Yeah, this is right. That make it safe to send signals concurrently. Windows has actually always supported this, and that's why Linux here like crying. Okay, by preventing PID reuse while they are still open handles. Yeah, open handles. This is why Tokyo closes the std. For the compatibility with the elliptic rise doesn't currently support WaitID on NetBSD on OpenBSD. We don't support officially RoadRunner on these platforms or an older version of OS X. We only support like most recent ones. There might be also some versions, so yeah, we don't care about this. Yeah, this is actually this is the same. Let me check if they use shared childs. Oh, this is from the same author. Yeah? Yeah, this is the same. I guess might be this is the older. Ting. I don't know why a wrapper around the child. Cross-platform library for OpenSource. So I'm not going to import these libraries. I'm just going to get some ideas, since we already invented these ideas by ourselves actually here. So we only need to like look at these libraries and the implementation of these libraries and just I don't know, re-implement some things in our code. Yeah. So. Okay, I guess we're going to do this on Tuesday, because on Monday I'm going to switch to Vim. So we can't speak about Vim and switch and use an JetBrains AD at the same time. This is just not how it works. We have to use Vim. We have to cry 2 times at the morning when we open the Vim and learn Vim, and at the evening when we are starting to write process pipelines in Rust. So 2 times a day. Super cool. Okay, so on a Monday, we are going to busy ourselves with a Vim configuration. I'm going to... Actually, I have some configuration already for the Vim here. For example, let me open Spiral, RoadRunner, Rust. Oh, we don't have... It's Gorich, Rust. Boom. This looks pretty good, I guess. So, open like Windows, floating Windows, I'm sorry, and all of these kind of colors, shiny colors, you know. And yeah, so we are going to switch completely into the Vim. So like with your keyboard, Jolly Jean, you're crying with your keyboards that you can type. I'm going to like support you because I'm start to cry in Vim. Because I stopped working in Vim, I guess 2 or 3 years ago, and I forgot completely everything. And for me, it would be like for you start typing on a split keyboard. For me, it would be like, okay, how to run this function in Vim, how to like run tests, how to compile, how to jump to the errors, how to oh my god, so this would be so much problems. But yeah, this is the way. This is the way, actually. Okay, guys, so Monday, Vim. Tuesday, we're going to continue our work with... I'm writing a server for the PHP, so I like pain. I born for the pain. Yeah, so Monday, Vim. Tuesday, we're going to continue our implementation. We're going to get some ideas from these libraries, OS pipe and this shared child. And yeah, so I think this is the plan somehow. On Monday, we also work slightly on this API. I guess like slightly polish our plan. Yeah. I guess that's it. So, thank you very much, guys, for being with me as usual. Have a super awesome weekend, and have a good evening as usual. Bye bye.